All right, welcome back everybody. This is the second video related to section 2 of unit 4 of AP Calculus, straight line motion connecting position, velocity, and acceleration. In the last video, we introduced position, velocity, and acceleration and the relationship between those three things and did a couple of examples. In this video, we're going to delve in and dig in a little bit more on the relationship between those, as well as some other motion characteristics that are related to those. And then we'll do a little bit more practice, and that'll be it with this section. All right. So in this box here, we're going to start off today by talking about information that you can get from velocity. Okay, now remember, velocity is the change in position with respect to time. Okay, so these four things are all things that we can tell about velocity, or pardon me, we can tell about an object's motion from its velocity. So let's start with the first one. What's true about velocity when an object is at rest? So if velocity is the change in position with respect to time, the change in position when an object is at rest is 0. And therefore, what's true about the velocity when the object is at rest? Velocity has to be equal to 0 when an object is at rest. So if you look at a velocity graph and you see that it is 0, that means that the object is at rest, even if it's only temporarily. All right, what's true about a velocity when an object is moving to the left or down? Okay, now depending on which direction of movement we're talking about, moving left on an, when we're talking about moving along an x-coordinate line, or moving down when we're talking about moving along a y-coordinate line. Anytime we're talking about that left or downward movement, we're moving towards the negative direction for position, and that means that the velocity is getting smaller, or pardon me, the position is getting smaller, which means that the velocity has to be negative. And conversely, what's true about the velocity when an object's moving to the right or up, that means that the velocity has to be positive. Okay. Last question here. What's true about velocity when an object changes direction? So when it's moving left, the velocity is negative. When it's moving up, the velocity's, left or right, or down or up. When it's moving left, the velocity is negative. When it's moving right, the velocity is positive. When it's moving down, the velocity is negative. When it's moving up, the velocity is positive. In any of these situations, when the object changes direction, that means that this velocity has to change sign. So what's true about velocity when an object changes direction? V of t changes sign from either positive to negative, or negative to positive. All right, let's see what I say here. Well, position, velocity, and acceleration are the primary characteristics of motion that we'll be concerned with in this course. There are some other related characteristics we will also be interested in finding on occasions. Displacement, that's the change in position from the starting point. So in order to find the displacement of any object at a moment in time, what we're going to do is we're going to take the position at that time and subtract away the position initially. So the displacement at time t is s of t minus s of 0. Distance traveled. Distance traveled is exactly what it sounds like in the context that you would have already known it. It's how far we've traveled. In this case, what we're going to need to do is we're going to need to use the position function, and we're also going to need to know when the object changes direction in order to calculate the total distance traveled. For instance, if I have an object that starts here and moves in this direction, and right here it changes direction and goes back to here, and then from here it changes direction again and goes to here. In order to find the total distance traveled, we would need this length, that change in position. We would need this change in position, and this change in position, and we would add them all together, and that would tell me the total distance that the object traveled. That's how we're going to calculate distance traveled. The next two are similar, average velocity and average acceleration. The velocity and acceleration that we defined in the previous video, those are the instantaneous velocity and the instantaneous acceleration, just like we talked earlier in the course about instantaneous rate of change and average rate of change. Instantaneous rate of change for velocity is the instantaneous velocity that we found in the last video. The average rate of change is the average velocity. And so instead of using the derivative, we're going to take the position function at one end of an interval and at the other end of an interval, take the difference of those and the difference of the x-coordinates, or t-coordinates more realistically, and that gives us the average velocity. And so the average velocity is the slope of position over an interval, as opposed to the derivative of position at a point. This ties in very strongly with what we talked about earlier in the course about instantaneous and average rates of change. Average acceleration, same idea, except in this case it's the slope of velocity over an interval. Okay, let's see, one other characteristic here, speed. Speed is the absolute value of velocity, and so the speed function is the absolute value of the velocity function. And if we're ever trying to find speed of an object, we would find the velocity function and then put that thing in absolute value, and that would give us a function representing the speed. Okay? So a couple more characteristics there, displacement and distance traveled. We'll talk about those more later in the course. Average velocity and average acceleration, the relationship between that and what we talked about with rates of change earlier in the course. And then, of course, speed. Since velocity is speed and direction, speed is just the magnitude of velocity, which we find by taking the absolute value of the velocity function. This next part is becoming very important in more recent years from what I've seen in the AP Calculus test. I've seen more and more questions in the time that I've taught the course about whether or not an object is speeding up or slowing down when we're talking about its motion. So an object is speeding up when the direction of velocity and acceleration are the same. Okay, so when the velocity function and the acceleration function have the same sign at that time, the object is speeding up, and that means velocity greater than 0 and acceleration greater than 0, or velocity less than 0 and acceleration less than 0. An object is slowing down when the direction of velocity and acceleration are different, or when the velocity and acceleration functions have opposite signs. So when velocity is positive and acceleration is negative, or vice versa, when velocity is negative and acceleration is positive. Okay, so if I'm ever asked a question, is this object speeding up or slowing down, what I want to do is I want to find the acceleration and velocity at that moment in time and see, are their signs the same or are their signs different? If they're the same, that means the object is speeding up. If they're different, that means the object is slowing down. All right, let's look at example 2, our last example from this particular portion of this section. And so we've got the position of a particle moving along the x-axis is modeled by the function x of t equals t cubed minus 5t squared plus 7 for t greater than or equal to 0, where x is measured in centimeters and t is measured in minutes. A little typo, there should be a d there, measured in minutes. Part A, find the displacement of the particle during the first 2 minutes. So displacement is the difference between its location at time 2 and its location at time 0. So we're just going to go in and find the position at time 2 and the position at time 0, subtract those, and we get the displacement. So the position at time 2 we substitute in here, gives us 2 cubed minus 5 times 2 squared plus 7. And we put the same in for times 0. Oops, that's a minus sign. And we calculate, and so we've got, let's see, 8 minus 20 plus 7 minus 7, and all this equals negative 12. And I want units. Displacement is a length or a distance, and so it is just measured in the length units for the problem. So the displacement is negative 12 centimeters. That means that the particle is 12 centimeters to the left of where it started. Part B, find the average velocity of the particle during the first 3 minutes. Average velocity is the slope of the position function, and if we're talking about during the first 3 minutes, that's for time 0 to time 3. Those are the first 3 minutes. So we want the position at 3 minus the position at 0. All over 3 minus 0. We go ahead and calculate those. We substitute 3 in here. That's, let's see, 27 minus 45 plus 7. So that's going to be negative 11. The position at 0, that's 0 minus 0 plus 7. So that's 7 we're taking away there. And so we end up with negative 18 over 3. Or negative 6, and the units for average velocity are the same as the units for velocity, so they're going to be centimeters per minute. Part C, find the velocity of the particle when t equals 4. So we want to take the derivative of our position function to get our velocity function. Velocity is equal to 3t squared minus 10t. And so the velocity at time 4 I get by just substituting 4 in here. And that gives me 48 minus 40, or 8. And again, the units for velocity in this problem are centimeters per minute. Acceleration of the particle when t is equal to 4. So we're first going to find the acceleration function just by taking the derivative of the velocity function. And so then the acceleration at time 4 is 6 times 4 minus 10. It's equal to 14 centimeters per minute per minute. And there's my acceleration at time 4. And then the last question here in this problem, is the particle speeding up or slowing down at t equals 4? Justify your answer. Well, we already found and this is why we did parts C and D, we already found the velocity and the acceleration at time 4. So is the particle speeding up or slowing down? Both of these values are positive. So it is speeding up because both v of t and a of t are positive at time 4. All right, that's going to bring us to the end of this video. You can come back and join us next time. Next time we're going to be still in section 4.2, but our focus in that particular set of videos is going to be on motion when we have information given to us in a table form or in a graph form instead of in algebraic form like we did in this one. All right, hope to see you then. Have a great rest of your day and enjoy it. Bye-bye.